So in this question, example number 2, we need to find the vector and the parametric equation of a line given the following information. The line passes through the point 6, -5, and 2. So those are my x naught, y naught, z naught. And parallel to this vector, so those are a, b, and c in the formula of the parametric equation. I will start with the parametric equation. Now the parametric equation, you have to write for me x equal what? It's equal to x naught plus a times t, comma, y equal y naught plus bt, finally z equal z naught plus ct. And all what we need to do is substitute the numbers. So what is x? X equal 6 plus t, because a is equal to 1, so I don't need to write it, comma, y equal to -5 plus 3t, comma, z equal 2 minus 2 over 3t. Just plug in the numbers, and this is the parametric equation. Now, from the parametric equation, we quickly can get the vector equation. Now, what is the vector equation? The vector equation, usually we write it as r, as a vector, equal r naught plus tv, which is very simple. You can write it down. It is just you write x, comma, y, comma, z. So here you have to write whatever you get as x, which is 6 plus t, comma, here you have to write the y. Finally, here you have to write the z. So you write just component of x, component of y, component of z. And this is, we call it vector, because we write it as a vector equation. And that's how we solve. Okay, in example number 3, we would like to find the parametric equation, and once we have the parametric equation, we can quickly find the vector equation. So we will focus now in this example on the parametric equation of the line given the following information. First information we have is the point. So I know that x naught is 0, y naught is 14, and z naught is -10. However, I don't know what is the parallel vector. All what I know is my line is parallel to another line, and those are the equation for the other line. So what is the idea here is the parallel vector of the line in the question is the same parallel vector of the given line. Why is this true? Because both lines are parallel. In the question, it gives me that the line I'm looking for is parallel to the line given by those equations. So the vector that parallel to both is already there. Now, how do we find the vector? Now, the vector, which we will call it v, we know that those are the numbers in front of t. Now, what are the numbers in front of t? We have 2, -3, 9, and those are my ABC. Remember, to find a vector, you need 3 numbers, a, b, and c, and here how we find them, because they are the number in front of t. Now, we go back. We have a point, x naught, y naught, z naught, and we have a vector with a, b, c. So all what we need to do is just we need to write the equations, and through the equations, we will find the parametric equations. So parametric equation all what you need to do is you need to write what is x. X is x naught plus at So this will be plus 2t. And what is x naught is 0. So the final answer will be just 2t. Next, I have 14. So the y will become y naught plus bt. This will be 14 negative 3t. 14 negative 3t. Finally, we will deal with the z in the same way we just did. And dealing with the z, this is negative 10 plus 9t. So the final answer is negative 10 plus 9t. And this is the parametric equation. We notice that the ABC at the end, the number in front of the t, is the same. Because this is the parallel vector, which is the same for both. The only difference is the number alone here without the t, because they are different lines passing through different. Okay, in example 5, we need to find the parametric and the symmetric equation of the line passing through 2 points. So usually to solve this kind of a question, it is always a good practice to have a small sketch of what you are going to do. Now, what do I mean by a small sketch? I have a line. This is my line. And I have 2 points. The first one is B1. And the second one is B2. Now, this is what we have here so far. Line with 2 points. Now, in order to find, let me just write it down here. In order to find the equation of a line, find an equation of a line, we need to find 2 pieces of information. First, we need to find a point, and in this case, it is already done for me because my point that I will choose is just B1, and B1 is 0, half, and 1. That means this is x naught, this is y naught, and this is. Now, what else do we need to find? We need to find a vector. And usually this vector is not just any vector. It should be a parallel vector, which we will call it V. And V, it must be A, B, and C. Now, if we have these 2 pieces of information, then we can quickly write the equation of a line. Now, unfortunately, we don't have the vector directly, but if we have 2 points on the line, I always can find a vector between them. Now, we ask ourselves, is this vector, the one in red, parallel to the line? Of course, it will be parallel to the line because it lives on the line itself. So for sure, it goes in the same direction as the line. So this can be used as the parallel vector. So what will be my V? My V will be just equal V1 and then B2, and we put the vector sign. And how we find the component of B1, B2? We just subtract the coordinate of B2 minus the coordinate of B1. So all what we need to do is 2 minus 0, and this is 1. And then 1 minus half, again half, negative 3, negative 1, negative 4, and those are my ABC. Once we have ABC, once we have the vector itself, we can find the equation of the line. And what is the equation of the line? Let me do here the symmetric one. Symmetric equation of a line. Symmetric equation. أول واحد بيصير 2. Okay. So here we'll have 2, half, negative 4. And now we will find the symmetric of the line, or symmetric equation. Now, what is the symmetric equation? It should be x minus x naught over a. So it will be x minus 0 over 2 equal negative half over half equal 1 over negative 4. And that's the symmetric. Of course, if you know the symmetric, you can quickly write the parametric. The number that will go with t is ABC, and the number without the t will be the numbers. Okay, in example 6, we have two parts. The first part is we need to find the parametric slash symmetric equation of a line passing through a point. I'm giving the point that the line is passing through, and I'm also given the parallel vector. So everything is ready for me. I know that this is A, this is B, this is C, and I know that this is x naught, y naught, z naught. And by this, I can quickly find the equation of the line. So the first part, part A, parametric equation of a line. It will be x equal x naught. It's not clear here, so it will be x naught plus AT. That's the first one. Second one will be y equal y naught plus BT. Finally, z will be equal to z naught plus CT. Now, if we know everything, we can just substitute. So what is x naught? X naught is 1 plus what is A? A is negative 1 times t. And this just gives me 1 negative t. This is 1 negative t. Now, for the y, we have y naught plus BT. What is y naught? Y naught is negative 5 plus, we just write what is b. In this question, it's minus 2 times t. All in all, it is negative 5, negative 2t. Finally, what we need to do is z naught plus ct, which is just 6, negative 3. We multiply it by t, and the answer will be 6, negative 3t. So by this, we found the parametric equation of the line. Of course, if we know what is the parametric equation, we can quickly find the symmetric equation as required in the question. And let me just remind you what is the symmetric equation. The symmetric equation is x minus x naught over A. And then equal to y minus y naught over B. Finally, it is z minus z naught over C. It is the same equation above, but without the t. So move the number to one side, and then ABC will be in the denominator. So what we will get is, we'll get x minus 1 divided by negative 1 equal y minus 5 divided by negative 2. And finally, will be z minus 6 divided by negative 3. And this is the symmetric equation. So this is the first part of the question where we need to find the equation of a line passing through this one. نعم؟ هاي plus A. Which is those numbers. Boom, boom, boom. Minus those numbers. Question? Okay, now let's go to part B. And as I told you, in part B, we need to find the intersection between this line with the 3 coordinate planes. So we have to solve this equation 3 times. The first one will be the intersection with, here part B. First, the intersection with XY plane. and we need to find the point. And then we solve the same question with YZ plane, and we find the point. And then we do the same question with XZ plane, and we find the point. So we will get 3 points, and those are 3 points where the line will intersect each of the coordinate planes. Now, what is XY plane? The characteristic of XY plane, we know it that there is no Z, so Z equal to 0. Now, how do we find the intersection? We have to write my Z equal to what? 0. Now, what is the Z in my line? The Z in my line is 6 minus 3t. So here we write 6 minus 3t equal to 0. Very quickly we can solve this question, and t will be equal to 2. Now, if we find t equal to 2, you need to tell me what is x, what is y, and what is z. Of course, z without doing anything, I know it should be 0. Now, how much x? We go back to the previous page and we substitute 2 instead of t. How much we get? Negative 1. Same thing here, we substitute 2. What do we get? Negative 9. So it will be just negative 1, negative 9. And of course, it's always a good practice to write it as a point. So as a point, it would be negative 1, negative 9, 0. So at this point, the line will intersect with the XY plane. Do you need me to do the other coordinates, or you know what to do? You know what to do for the other coordinate planes? Okay. In example number 8, we need to find the vector equation of the line segment. Remember, the line segment has a starting point and end point, and it's given to me that this is my starting point because it starts from this point, and this is the end point because I'm going to this point here. So what is the equation of a line segment? We write r of t equal 1 minus t times r0, which is the vector representing the initial point, plus t times r1, which is the vector representing the end point. And remember, my t, it's only between 0 and 1, so that I can have a range for the t, I will have a range for the points. Now, all what we need to do is we just need to write the equation here. What is r0? It is the vector representing by this point, plus t times this vector here, which is 7, 6. Now we just have to distribute everything. So if I take 6 times 1 minus t, this directly gives me 6 minus 6t, comma, negative 1 plus t, comma, finally 9 minus 9t, and that's the first one. Plus, second one is only 7t, 6t, and 0. Now you have to join them together. So how do we add vectors? We add the first with the first, second with the second, and third with the third. So if we do that, it will be 6 plus t, comma. Now this one will be negative 1 plus 7t, comma, 9 minus 9t. And that's the vector equation for the line. So in this question, we need to check whether the line L1, given by this parametric equation, is parallel to line number 2, which is given by another set of parametric equation. So the idea to check if the two lines are parallel, is to check if the parallel vectors, I will call them v1, v2, are parallel. Well, what are the parallel vector? V1 is the number in front of the parameter t. So it is negative 12, 9, and negative 3. V2 are the numbers in front of the parameter s, because s is the parameter for L2. So this would be 8, negative 6, 2. So this is V1 and this is V2. Now, how do we check if two vectors are parallel? We said we have three methods. The first method is to check if one of them is scalar multiple of the other, which means if 8 divided by negative 12 is the same as negative 6 divided by 9, same as 2 with negative 3. And in this case, I think the answer would be yes. If we check this one, it would be equal to this one. It would be equal to this one. So the answer here, yes, these are parallel, because V2 is a scalar multiple of V1.